Hello students, hope so you are fine and you're doing well in your studies. Today our topic of discussion is the alkanes and paper 2, in which we will discuss about the questions of alkanes. So let's start with the question number 1. Alkanes and alkenes both react with the bromine. Explain how and why bromine can be used to distinguish between alkene and an alkane. Actually, here we can see when bromine, water or aqueous bromine react with the alkene, actually the pink color of bromine is discharged and it become the colorless, while when alkane reacts with the bromine, alkane in the presence of sunlight or UV rays, it will undergo the free radical substitution, and free radical substitution, actually there is no effect decolorization, there is no effect on the color of the bromine. So here we can see actually question number B, the reaction of ethane with the bromine forms a mixture of products. State essential condition for this reaction. Actually, as I mentioned earlier, when alkanes or ethane reacts with the bromine, it produces the actually monohaloalkanes or alkyl halide, and the necessary condition are the sunlight and the UV rays. So in the next question, part 2, give the full name of the mechanism. Actually, the full name of mechanism is free radical substitution. So this is the name of the full mechanism. So the next question, give the equation for the termination step that could occur producing a hydrocarbon. So here we can't produce the Rx because Rx is not the hydrocarbon, even though it is an organic compound. Do you know what is the difference between organic compounds and hydrocarbons? Hydrocarbons contain only hydrogen and carbon. For example, alkanes, alkenes and alkynes. But the organic compound contain the both of these, but plus their derivatives. For example, we have alcohol, ROH is organic compound even though it contains oxygen. So carboxylic acid or carbonyl groups are also examples of organic compound but not the hydrocarbon. So we have option that after termination there should be a hydrocarbon, only carbon and hydrogen must be present. So it may be an alkane. So it is for the ethane. So I can take ethane free radical C2H5 and it will give us C4H10. So this is the termination step for the preparation of hydrocarbon. Give the equation for the one propagation step involved in the formation of dibromoethane from bromoethane during this reaction. So for this purpose we have bromoethane plus bromine free radical, and it will give us actually the C2H5 BrC4H5 free radical plus HBr. And after this step, in the next step, these are the reactants and the products. These are the reactions actually with the difference of Br2, so we can add C4H2Br2. So this is the actually for the preparation of one propagation steps. Question number 2 is very easy. Crude oil is processed to give a wide variety of hydrocarbons. Give the names of one physical process and one chemical process carried out during the processing of the crude oil. Actually, the physical process is fractional distillation of crude oil or petroleum. So fractional distillation. And the chemical process is actually the cracking, in which we break down the larger hydrocarbon substances into smaller hydrocarbons. So this is the definition of cracking. So here, question number B, alkanes and alkenes can both be obtained from the crude oil. Explain why alkanes are unreactive. Actually, alkanes are also known as paraffins, which means less reactive. So why these are called as the paraffins? Because due to the non-polar nature of carbon hydrogen bonds or carbon carbon bonds, and number 2, inertness of sigma bonds, because we know alkanes contain only the sigma bond. So alkanes contain only sigma bond, due to which we can say alkanes are very less reactive, or we can say these are the paraffins. So in the second part, state the bond angles in the molecule of ethane and ethene. So the bond angle, as we know, in ethane there are four bonds and sp3 hybridization. So for sp3 hybridization, angle should be 109.5 or 109 exactly. And we can say ethene we know, for hybridization sake, we consider the double bond as a single bond. We can say there is 3 bonds, or we can say streak number is 3. So hybridization must be sp2, and in the sp2 hybridization there is no lone pair, there should be ideal angle, that is 120. So in the next question, question part 3, state the shape of each molecule in terms of arrangement of the atoms bonded to each carbon atom. So we can say ethane is the tetrahedral because sp3 hybridization, and ethene is the trigonal planar. So in the 4th part, explain why these molecules have different shapes in terms of the carbon-carbon bonds present. As we know, because they are different in structure, and we can say the all bonds are sigma bonds in alkane, and in alkene not all the bonds are sigma bonds, actually one pi bond also present. And as we know, pi bond is diffused bond in which electrons are diffused, and so we can say there are different that is the reason for the different shapes of these two structures. In the next question, use series of equations to describe the mechanism for the reaction of ethane with the chlorine. So this is the free radical substitution mechanism to form chloroethane. Name the steps in this reaction. So first is the initiation step, in which chlorine molecule forms chlorine free radical. So this is the initiation step, this is known as initiation. And what is the propagation? Actually, in my P1 lectures I told you guys about, if you see only free radical on the product sides, so this is the initiation. If you can see the free radical on the both side, products as well as reactants, so it may be the propagation step. And if you see free radical only on the reactant side, it is the termination step. So this is the identification, and now we are writing this. So initiation, and after initiation there is a propagation. So I can see C2H6 plus Cl free radical, it forms C2H5 free radical plus HCl. And in the next step, C2H5 free radical plus Cl, and it will form C2H5Cl plus Cl free radical. So this is the, both steps are the propagation steps. So in the termination step, C2H5 free radical plus Cl free radical, it will give us C2H5Cl. So this is the termination step. Thank you. Write an equation to show the butane how could be produced by the as I discussed in my previous lecture.